This is problem 5 from your exam review worksheet. This is a problem on op amps from chapter 4. And we are to determine the gain, VL over VS, for this circuit and to specify the linear range of VS for RL equal to 4 kiloohms. So you have to analyze this circuit. It is a non-inverting amplifier, but you don't need to know that to work the problem. So what we're going to do first is we want to figure out, if we can, what VP is, because we know VP has to equal VN. And we know that IP equals IN equals 0. So IP is labeled here, that's going to be 0, but VP is not necessarily 0. So to find out what VP is, we realize that VP is going to be the same as VS prime here, and we're going to use VS prime instead of VS. And here's our actual voltage source, and VS prime is right in the middle from the voltage source to the ground. And so if we want to find the voltage right here, we can use voltage division. So VS prime equals VS times, this is 0, and so we want the actual voltage here. So we want to find the voltage difference across the 20K ohm resistor. So VS times 20K over the sum of the two resistors, which is 20K plus 5K. And so VS prime equals 0.8 VS Now let's look at trying to find V out. So V out is right here. We know that there is no current in the wire going into the negative because IN equals IP equals 0. So the current here is 0. And since the current here equals 0, any current has to be flowing through here, and the potential will be the same everywhere here. And we actually know what that potential is. The voltage we just found for VS prime is 0.8 VS. So this also has to be 0.8 VS. But it's also midway between VO and ground. So if we want to find out the voltage right here, then using voltage division, we would say that 0.8 VS equals, and now we're going to use voltage division on this because that is the point in the middle, equals 10 kiloohms over 10 plus 70 kiloohms times V out. So that's saying that the voltage between V out and ground is divided, and we have a division point here, and the voltage, the potential difference from here to here is going to be 10 over 10 plus 70K. And we actually know what the voltage is at this middle point. It's 0.8 VS. So now we have 0.8 VS equals, that was 10K, equals 10K over 80K, or 1/8 V out, or now we have that V out equals 6.4 Vs. So now let's look at VL, and we can do voltage division again on VL, starting from V out and going to ground. So we know that VL will equal V out times RL over RL plus 4 kiloohms. Well, RL is given in the problem to be 4 kiloohms, so VL equals V out times 4 over 8 is 1/2. So VL equals V out over 2. Now our gain is VL over Vs. So let's find that, because that's what one of the things we're instructed to find. Gain equals VL over Vs. Okay, so VL is V out over 2 over Vs. But V out was 0.64 Vs, so this is 0.64 Vs over 2 over Vs. So the Vs's cancel. I'm sorry, that was 6.4, not 0.64. And the Vs's cancel, and you have 6.4 over 2, which equals 3.2. So that's our gain. Okay, we also have to find the linear range, and the linear range is governed by the requirement that the absolute value of V out has to be less than or equal to VCC. And the absolute value of V out, so we have V out is 6.4 Vs. Has to be less than or equal to, absolute value, has to be less than or equal to VCC, which is given to be 6 volts. So negative 6 volts is less than or equal to 6.4 Vs is less than or equal to 6 volts, just setting up the absolute value inequality. And then divide everything by 6.4. And 6 divided by 6.4 is 0.9375. So that is the linear range for this op amp.